Hello, good evening. You join us here live. It's just on 10 o'clock here in the UK. We are going to be doing a small discussion regarding the Commodore PET 6502 based systems and the fact that I'm going to try and recreate the hardware and for several machines in a possibly what do we call it, universal 8-bit modulated system. That's the idea anyway. So, first of all, we're going to have a quick look at the Commodore PET. If anybody's played one of these items, you'll be quite familiar with one of these. So, this is the 8032 motherboard. And this is what we're going to be looking at and taking ideas from. The system that I'm going to try and devise will be based on 8-bit systems that can be based on possibly the Z88 and possibly the 65816 if later that is possible. So we'll look into that. I must start by saying that my knowledge is very basic on these ideas. So anybody can sort of help towards this. Any information, any ideas, any positive thoughts, we can look into the possibility of integrating these ideas and making the system possible. So without much ado, we will have a quick look at the board and dissect that in the way that I've been looking at it. This may not necessarily be the way that technical, proper bolts would look at it, but this is my views. So once again, we'll be looking at this device here. So here we have a PET motherboard. I hope we're in shot. With this particular device, we have several items that are of interest here that we need to know about. This here is the main system RAM. The system RAM comprises of dynamic memories which have to be refreshed. So those are also very power hungry, and I intend to change this by going to static RAM and also drop the chip count by using more modern items. So that's the main 32K of RAM. Here are two more RAM chips. These are for the video. There's 4 here on this particular model because this is an 80 column set. So that's the video RAM. That's something else that I'm looking at changing that to a larger size on one chip with more modern chips that will produce that will take less current. The ROMs here will be modified to one large low power ROM, and the rest of it will take as we are. The CPU which I have here, these are lower powered. These are the 65C02. So that leads us to possibly taking the machine faster, possibly up to 4 meg, depending on what I can do. So that's what the plans are essentially with this. Now the thing that we need to know about the Commodore PET and all 6502 based systems is the memory starts at the bottom. If we look at the addressing of any 6502 based system, there are 65535 locations available with 16-bit addressing. These are addressed in binary by 16 lines. So A0 to A15 are our address lines. Knowing that A15 is the highest one, that'll take us halfway up the memory map. Now the interesting point about the Commodores, and anything else that seems to be 6502, from 0 to 32768 is usually free for memory. Now, like I said before, the idea of doing things, I was going to use a set of 8K RAMs and a 74LS 1 through 8 decoder, like what I have here in my first part, running video RAM here. But I've discovered a little chip which I purchased the other day. If I just get one out, we can have a look. These particular ones are the MCM 6206CP20. One little package that will give us 32K of RAM by 8 bits directly. That can be addressed from 0 to 32768, or 32767 to be fair, giving us the full lower end. Now the bottom half of the, at the very bottom, of course, we'll have 0 page. That'll all be taken into account in that particular chip. So that's the plan with the bottom end of the memory. Further to that, as I said, memory for video is going to be the 6264, which I have here. And then the ROMs sit up a bit further. They're easy to address a bigger chip because at the end of the day, if A15 is low, we must be on the bottom half of the memory. So we can address that in just by using A15 and using all the other address lines connected directly. That'll give us our bottom end memory. So that's the plan for that bit. Video in the Commodore PET, and it seems like the Acorn Atom, starts at 32768, which is quite handy. So here on this first part of my prototyping board is a 6847 video processor. This will generate our graphics. It has its own memory. Now, of course, this being a separate affair, has to have its own separate data and address bus. So the next stage, of course, is to integrate a couple of chips down the bottom here, which will have, hang on, we'll go and check, see what's coming up soon. Right, okay, that's fine. Yeah. So we will be looking towards sharing these two buses, address and data buses, one for the video and one for the main CPU. So I've got some 74LS245 address buffers here, which can be switched to a status where they don't exist, and they'll only come in when necessary, when we've got them at 32768. So that's the main prototyping board here of the video display, which I actually have up and running. The plan that I've got at this moment is when I've wired these bidirectional buffers up, we can connect these to one of the ROM sockets of the PET, knowing its addressing, steal a read and write line from somewhere else on the memory line somewhere, which I can apply. Bring it in with one of the with the CE pin that's available on one of the expansion ROMs, and feed it directly with data. So that's the idea. We can program the RAM and hopefully get a display out. So that's the first start, which I intend to look into so far. If we have a quick look at this little board, all we've got here basically is the same sort of setup as you'd find in an Acorn Atom. We have a chip here which is our clock generator, which generates at 3.5 megahertz. We have a small video output buffer here, the 6847 itself, and of course the full memory. So that's the next stage, of course, is what I'm going to do is I'm going to try and connect that up and send it some data. I've had it running where we've got some video directly, so that's the first plan. But from what I can see, in this particular setup, there is a lot of glue logic on the original PET board which we have here. And a lot of this logic is only necessary because we're using dynamic RAMs and ROMs that were of very small size. So a lot of things were needed for, say, addressing small areas in together to make one big memory. We apologise for the technical difficulties we're having here at the live transmissions. You have to bear with us because, as I say, this is a live setup and we are desperately trying to get things back online. This is a first time crack at doing something like this. So there you go. So here we are. We're looking here at the 8032 at this present moment, just amusing itself by doing some random display that I've set up. So, right, we are back. Hopefully we'll stay on. This is the trouble with using antiquated equipment, I suppose. Let's have a little look at the prototype board that we've got so far. So this is what we are looking at. You can see, I don't suppose the numbers will come up too well on this, but we have the 6847, which is a video generator. This is only capable of 32 columns by 16 rows, which is all well and good, but that actually led me a merry dance. Any of you that are technical, obviously the 6847 has its own address and data lines which go to the memory chip here. Now the problem I had with this device was when I was trying to get this sorted to my little oscillator here. So just checking the videos so I can see what's going on. The oscillator chip here had a problem. I'd wired it wrong. These things happen when you're experimenting. Was actually giving out the wrong frequencies, and I couldn't get the telly to sync. And I'd also got this little amplifier connected slightly wrong, and we had inverted the video out. So I was confused as to why this here was only addressing the only lines that were running were up to about address line 8. And I worked it out that that would only be sort of like counting up to 512, and working out that 32 times 16, of course, is 512 bytes. So it's actually only addressing 512, which is all it needed to do because it's locked into text mode only. So that's that. We have here 3 devices which are going to allow or not allow the CPU bus to talk to it directly. These are 74LS 245s. These can be tri-stated, which of course means that they won't exist on the video bus, on the CPU bus once the data is sent, and that allows this device here to continue writing to reading from its RAM and displaying it out of the video socket. So that's how that's going to work. So all we're going to have out here are 8 data lines, 8 address lines. No, wrong again. 12 address lines. Is that 13? Because it's A12, isn't it? So 13 address lines, 8 data lines. Yes, I can be corrected. And I've got a write line, read-write line, so we can read and write from it. And there will also be an enable line, which will bring that into use when the CPU wishes to talk. So that's the basic plans on this. Now, a lot of people have said about wire wrapping. I don't use wire wrapping. I've never done that before. I've never done this before, and this is a bit untidy, but here we are. This is what we're dealing with here. These are just random bits of wire that are snipped, tacked, put into place, and these wires here are actually randomly put for the moment for test purposes. These set the different modes for text, video, inverse, and at the moment they're just sort of like connected to the ground line. So that's what we have here. I have to connect at some point the pins from these chips, the address and data lines, and that will make that function. So that's that bit. So we're going to look a bit further on. We can have a proper look at that. These memory chips. So if you just bear with me. These are the latest that I've just picked up. A lot of these come up rather cheap these days, which is rather handy to get these retro ICs. The bonus, of course, for these is, as I said, they're static, they're directly connected, they're 8 bits, and they will allow you to to use directly without having to worry about refreshing. So yes, that's the whole of the bottom 32K sorted to and dealt with without further ado. So that's the plan of that one. So we have a load of those to experiment with. These ones too are also static, 8 bits, as opposed to the 2114s, which of course were 4-bit. So that's the plans with that. What I'm going to do is just look at how this is going to be. What we're going to do is I'm going to draw a small... You'll have to excuse me because I'm trying to draw and hold the camera at the same time. That is terrible. Good lord. Do bear with me. Right, I'm not a one that deals with hexadecimal, so you'll have to bear with that. So this is going to be where I'm going to start here, which is 0. This, of course, on the top here is 3, 2, 7, 6, 7. And that will be all RAM. 32K. So that's quite simple. As I said with that, as long as A15 is low, we will be below 32768. So that makes that quite easy to deal with decoding wise. We can run that straight off of A15 itself. Above here we will have a small area here 32768 to 32768 plus 512, which will be our video RAM. And as with all 6502 based systems, the ROMs and the I/O sit at the top. So that's the plans I'm going to try and use. Rather than sort of what I can see of the PET, there is a multiple system that basically divides each and every segment into chunks, so that you can welcome back again. Thank you for bearing with us. Further technical difficulties. So the advice on this is this is quite amusing, really, as the old Commodore PET has sat here all night, just randomly poking 160s and 102s to its screen. The advice is, of course, is using old tech. And as we just show you here, we have this is what is doing our broadcasting. This old lappy here, which of course hasn't been serviced at this point in time, is to cut this loose. It gives people any chance to have a think about if there's anything that could be talked into a little bit further, or any questions or whatever, any info that you wish to see. I hope to bring the display board up and running, so you can see that going, and I may even consider connecting it to the spare ROM socket, so we can actually send it some data from the good old PET and see whether we can actually get some meaningful text rather than just than weird and wonderful characters. So that's the next plan. So hopefully you'll see us in the next broadcaster. It might actually be better if we do an edited video and just post that and then put some lives up, put some infos up, so that's the plan anyway. So we'll take it from there. So do bear with us, and we apologise for the problems that we are incurring, as it were, but these are the joys of live streaming. So we'll hope to see some more soon. Yes, thank you, Chris. So, as you can see. So from there, from me, I'm going to say cheerio. I'm Telemedic. This, of course, here being Chris at Bully Media, trying his very, very best, and my son, my son is sitting over the back there, just casually taking it in. So, have a very good night. Thanks for watching him.